Hi, this is Mrs. Earl with another video tutorial, Simplifying with Exponents. If we look at this first example, there are two ways that we can approach it. The first way is to multiply the numerators and then multiply the denominators. In this example, or in this method, we would have 7 to the third times 7 to the negative sixth over 8 to the negative 4 times 8 to the second. Simplified, that would be 7, 3 plus negative 6 over 8, and then we have the exponent of negative 4 plus 2. When we simplify that, we end up with 7. 3 plus negative 6 is the negative third power. Negative 4 plus 2 is 8 to the negative 2 power. When we're done, we want to make sure that we rewrite the exponents as positives. So we flip the 8 to the top, 8 to the positive 2, flip the 7 with the negative 3 to the bottom, and it's 7 to the third. So our answer is 8 squared over 7 cubed. This would be your final simplified answer in exponential form. Problem 17 asks you to rewrite the expressions without negatives. So what I want you to do is press pause, solve number 17, and then press play to check your work. Then move on to the next problem. Again, pressing pause, solving the problem, and then pressing play to check your work. Go ahead and do number 17 now. All right, let's look at number 17 together now. To write without negative exponents, we need to use the reciprocal. So the 8 comes to the top with a positive 3, and the 3 comes to the bottom with a positive 2, and your answer is 8 cubed over 3 squared. Go ahead and do number 18 and press pause. All right, for number 18, you'll notice that the 2 to the 4th power is already positive, so we're going to leave it. We don't need to do anything to it. But we do need to bring the 3 to the negative 6 up. So now we have 3 to the positive 6th. And our final answer is 2 to the 4th times 3 to the 6th. Go ahead and do number 19 and then press pause. For number 19, you'll notice that the 2 to the 4th can stay where it is, but we need to take 5 to the negative 3 and move it to the bottom because it's really 5 over 1. So now we have 2 to the 4th power over 5 to the 3rd power is our final answer. Okay, push pause and do number 20. For number 20, we're going to leave the 7 squared on the bottom because it's already positive, but we need to move the 11 to the negative 3 to the bottom. So now we have 7 squared times 11 to the 3rd, and on top we have 1, and that is your final answer. Simplify the expressions. Hit pause, solve number 1, and then hit play to check your work. Hit pause now. For number 1, I like to rewrite the problems without the elementary division sign as 10 to the 4th over 10 to the negative 3. I then can rewrite the problem by changing the negative exponent into a positive. So now I have 10 to the 4th times 10 to the positive 3. On the bottom, there's nothing, only a 1 on the bottom. When I simplify that, I get 10 to the 7th power because I add 4 plus 3. Your second option for solving the same problem is to, the shortcut is to subtract the exponents. So when you divide, so if I do 10, 4 minus negative 3. Well, 4 minus negative 3 is really 4 plus 3, and now I have 10 to the 7th power. Same answer. Both methods worked perfectly. Let's look at problem number 2. Go ahead and push pause, solve the problem, and then push play to check your work. All right, for number 2, I'm just going to use the shortcut, and I'm going to do 5, negative 2, plus 5. Multiplication, we add the exponents is the shortcut. And the answer is 5 to the 3rd power. Negative 2 plus 5 is the 3rd power. If I want to do it the longer way, I could change 5 to the negative 2 into 1 over 5 to the positive 2 and multiply that by 5 to the 5th power, which of course is over 1. I now have 5 to the 5th over 5 to the 2nd. It's now a division problem. When you divide exponents, you subtract them. So 5 minus 2 equals 5 to the 3rd power. Here are a couple more problems. Push pause, solve them, and then push play to check your work. In this example, the bases are different. Therefore, we cannot divide, we can't just subtract the exponents. Instead, it says rewrite using only positive exponents. So, we would have to flip both of them, and we have 2 to the 7th over 5 squared, and that would be your final answer. For number 5, push pause, solve it, and then push play to check your work. For number 5, the 6 to the 3rd is already positive. We leave it on top, but we also need to move this 11 to the top, and the exponent becomes positive. And our answer is 6 to the 3rd power times 11 squared. And this is our final answer. For number 7, push pause, solve the problem, and then push play to check your work. For number 7, I'm going to start by rewriting the problems using positive exponents. So actually, you know what? I'm going to put the 4's on top. So if I just flip this 4 to the top and this 6 to the bottom, I now have 4 to the negative 5 over 6 to the 7th times 4 to the positive 3 over 6 squared. This gives me the bases of 6 together and the bases of 4 together. Now it's a multiplication problem, so I can add the exponents. Negative 5 plus 3 gives me 4 to the negative 2 power, 6, and I can do 7 plus 2, add the exponents, gives me 6 to the 9th power. Now, the last thing I need to do, the problem says to write them with positive exponents, I need to move that 4 to the bottom. So now I have 1 over 4 squared times 6 to the 9th. And that is the final answer. For number 8, push pause, solve it, and then push play to check your work. For number 8, it is a multiplication problem, and I already have the bases together, so I'm simply going to add the exponents. 2, and I have negative 5 plus negative 4, which gives me 2 to the 9th power, negative 9th power. And on the bottom, I have 11 as the base, 3 plus negative 7. 3 plus negative 7 is negative 4. So now I have 2 to the negative 9th divided by 11 to the negative 4th. But my exponents aren't positive, so I need to write them as the reciprocal. 11 to the positive 4 divided by 2 to to the positive ninth. And that is my final answer.